Welcome to SSR Pharma Media, your trusted source for pharma knowledge. PIC MCQ series, your exam power boost. Pharmaceutical Inorganic Chemistry. Today we are going to discuss about neutralization curves. Prepare, practice, succeed. So first of all, what is acid-base titration? In acid-base titrations, we have discussed about acid-base theories and theories of acid-base indicator, classification of acid-base titration, and preparation standardization of titrant, and theories involved in titration of weak acid, weak, strong, weak, very weak acids and bases. Today we are going to discuss about neutralization curve only. So what is neutralization curve? So neutralization curve is also called as titration curve. So is a graph that represents the change in pH of an acid or base solutions as a titrant is added during an acid-base titration. It is typically plotted as volume of titrant added. It is present in the x-axis versus pH in the y-axis. So the shape of neutralization curve depends on the strength of acids and base involved. So this curve helps to understand acid-base strength and pKa, pKb or Ka divided by Kb values. So acids, ionization constant of acids, ionization constant of base, and acids divided by base values. Select a suitable indicators. So it is used for selection of suitable indicators in the titrations. And analyze the buffer regions and pH changes during titration. Identify the equivalence point, and also it is used to detect the endpoint detection in volumetric analysis. So there are four types of neutralization curve here explained as strong acid versus strong base acid versus weak base, weak acid versus strong base, weak acid versus weak base. So always in neutralization curve, so x-axis is a titrant added and y-axis is the pH. So we'll see the question. Neutralization curves are graphical plots representing which of the following? So the answer is option B, pH versus volume of titrant. The primary purpose of your neutralization curve is to determine, so the answer is option C, equivalence point of an acids and base. So this is the primary purpose of neutralization curve, to identify the equivalent point of an acids and base titration. In a neutralization curve, the equivalence point appears as, so the answer is option C, a sharp change in pH. That means in inflection point. So in sharp curve at the equivalence point, the pH changes rapidly due to almost complete reactions between acids and base, producing an inflection point of the curve. So that means inflection means while we are plotting the neutralization curve, so these two, this point and this point is called as inflection. So middle point will take consider as a equivalence point, that means end point. So we'll see one by one neutralization curve. First, strong acid versus strong base. So in here both acids and base are strong, means it's both are fully dissociate. So when acids are base, when we are dissolving in water, it must dissociate completely. So that type of acids and base are called as strong acids and strong base. So in this titration, the curve is steepened. It is symmetrically S-shaped curve. It's a very sharp rise near midpoint, very steep. So vertical rise of pH between 4 to 10. So nearly the equivalence point pH 7, at pH 7. So while doing the titration of strong acids, for example, HCl versus NaOH, so here phenolphthalein and methyl orange is used because these two indicators between this pH 4 to 10. So nearly phenolphthalein is 4.4, so methyl orange is 4.4 it comes, and phenolphthalein 8 to 10, pH of the phenolphthalein may 8 to 10. So because of the pH changes in this titration 4 to 10, we are using these two as a indicator. While doing this titration, we will take the acids in a conical flask like HCl in a conical flask, and NaOH will take in the burette. Burette will take. So here volume of added base, that means volume of NaOH, will add each addition 1 ml. So after adding 1 ml, we record the changes of the pH. So initially in HCl it is there in the conical flask, so there is no changes in the pH, so it starts from 0, and when we are adding the NaOH, slightly increases in each additions, slightly increases. So after the near to the end point, suddenly it steepen the curve and it's go to the again flat. The reason is, so after the end point, all the HCl's are reacted completely with the NaOH, so only remaining in unreacted NaOH may be present. When we are adding NaOH, the unreacted if it is present, so suddenly it steepen the curve. And after that, we will add again NaOH, keep on adding NaOH. So there is no change in the pH, it's making to the alkaline pH. So it's acidic pH to alkaline pH. So between these two inflection, the center point is called equivalent points at 7. So this is the concept. So in a titration of HCl with NaOH, the pH at equivalence point is approximately. So the answer is option C, pH 7. So at pH 7 only acid base, strong acid base plus strong base reacted to produce a salt at pH 7. Which of the following indicators is most suitable for strong acids versus and strong base titration? So the answer is option C, both phenolphthalein and methyl orange, because the pH 4 to 10 will get the end point in this strong acid versus strong base titration. So both the indicators are suitable. The titration curve of the strong acid by a strong base shows, so option C, is a steep and symmetrical curve. That means S-type curve will get it. Before equivalence point in a strong acid versus strong base titration, pH depends on, so option C, the excess hydrogen ion concentration. So before starting the equivalence point, before starting the titration, the pH of this solution of HCl is due to hydrogen H plus ion. The pH of the solution is due to H plus ion that produced by the HCl. So after adding NaOH, so the HCl, NaOH, OH react with hydrogen ion to form water. So the hydrogen ion get neutralized, and after the end point go to the alkaline pH because of the OH minus ion increases. After equivalence point, added strong base causes increase in pH due to excess OH minus ion, that means alkaline pH. Next, neutralization curve in that strong acid versus weak base. So in this titration, the base is weak base. Weak base means, first of all, you must know about that, it partially ionized. So for example, ammonia or ammonium hydroxide is the example. Ammonia or ammonium hydroxide is example for weak base. So when we are dissolving in this weak base in a water, so this OH minus ion, it will not completely dissociate into OH minus ion from the ammonium ion. it will not come out easily. So partially it used to come out. So that's why this is called weak base. It's an example for weak base. Strong acids I told. So when we dissolve in water, easily it donates the hydrogen ion immediately. So next, the buffer region appears before the steep drop. At half equivalence, pH is equal to pKa of the conjugate acids. So at the half neutralization point, pH is equal to pKa. pKa is the ionization constant of conjugate acid. And equivalence point occurs at pH above 7 because the conjugate acid makes solution acidic. So when we are doing this titration, so initially we will take the HCl in the conical flask, and ammonium hydroxide will take in the burette. Ammonium hydroxide is the base, will take in the burette. So volume of acid added, will take HCl in the burette and ammonium hydroxide in the conical flask will take. So volume of acid is added. When we are adding the volume of acid, initially the pH of this titration is high because it's a weak base. So it's a high pH. When we are adding HCl, when we are adding HCl react with the OH ion and it become the equivalence point and it will get to steep inflection. So center of this point is called equivalence point. So it is occurs above 7. So because it is a weak base, so weak base pH will not decrease suddenly due to weak base. At the equivalence point in strong acid plus weak base titration is so above 7. Which indicator is best for strong acid and weak base titration? So option B, methyl orange. So in this strong acids versus weak base titration, methyl orange is used as a indicator, not a phenolphthalein. So because phenolphthalein is a pH 4 to 8 to 10, so in this titration phenolphthalein may not be used. So methyl orange is used. During strong acid versus weak base titration, a buffer region is seen due to option B, weak base plus its conjugate base. So acid, At a half equivalence point, a strong acid versus weak base titration is option A, pH is equal to pKa of conjugate acid. Before equivalence, the pH is controlled by weak base equilibrium. So weak base will not dissociate fastly into OH minus ion. So the pH is controlled by weak base equilibrium. Next, neutralization curve in that weak acid versus strong base. So here weak acid example acetic acid, because acetic acid is a partially dissociate into H plus ion, and strong base example NaOH. So NaOH is always taken in the conical flask and acetic acid is taken in sodium hydroxide is taken in the burette and acetic acid is taken in the conical flask. It's a weak acid and strong base. So initially the pH of the acetic acid is very low, acidic pH, so very low. That means in the buffer zone. When adding NaOH, so slightly rises the pH of the solutions, and after the endpoint it go into the steep. So buffer region appears nearly in this curve. So half equivalence point pH is equal to pKa. Equivalence point occurs at below 7 due to the formation of conjugate base. So in this, initially acetic acid is there, so as a acidic pH. So after that adding the NaOH react with the acetic acid and it form the salt. So after the end point After the endpoint, only alkaline pH, it's go to the steep. And between these two inflection, the center point is called equivalence point. That means endpoint. So here indicator is phenolphthalein is used. The pH at half equivalence in weak acid, strong base titration equals. So option B, pH is equal to pKa. The equivalence point of weak acid plus strong base titration lies at. So option C is the answer. More than, less than 7. The suitable indicator for weak acids versus strong base titration is option C, bromothymol blue. Which feature is characteristic of weak acid and strong base titration curve? So option B, earlier buffer region. At equivalent point, the species responsible for pH less than 7 is, so option C, conjugate base hydrolysis. Last type, neutralization curve, weak acid versus weak base. So weak acid, very weak acids, example acetic acids or boric acids, and very weak base is called ammonium hydroxide or aniline. So and minimum pH change during the titration. The curve is shallow and may lack a clear inflection point. Almost flat curve. So almost is like a flat curve. Very small slope change. The endpoint visually indistinguishable. So no clear equivalence region. So here almost the peak is gradually increased. So not like a S-type curve. So in neutralization curve, we must get S-type curve. Then only it is very easy to identify the equivalence point between these two inflection. This is a center point is called an equivalence point. But in this titration, so it is gradually increasing. So it's very difficult to identify the equivalence point. So it is type of flat curve. The endpoint is not visually detectable, requiring a pH meter or potentiometric meter. So in this type of titrations, we use pH meter or mixed type of indicator also may used. Weak, very weak acids and base show titration curve with very small slope change. Indicators generally fails for very weak acids and weak base because pH jump is too small. So option B is the correct answer. So indicator generally fails, but slightly may work. The mixed type of indicator may also used. Mixed indicator, not a single indicator. Mixed indicator may used. The preferred method for determining endpoint of very weak base and acids and base titration is, so option C, potentiometric titration using a pH meter. The inflection point in titration of very weak system is partially absent. The titration of boric acid is difficult because its Ka ionization constant is very low. Answer is very low. The boric acid requires a complexing agent during titration because option C, it behaves as a very weak acid. So in order to make a strong acids, we need a complexing agent. So next we'll see the some terms definitions. pH. What is pH? Measure of acidity or alkalinity is defined as the pH. So pH is also called as So the solution's ability to pH is the measure of acidity or alkalinity. So defined as pH is a negative logarithm of hydrogen ion concentration. So this is called pH. And buffer. So what is buffer? So buffer means it's a solution that resists in pH when small amount of acids or base are added. When we are adding small amount of acids or base, the change of pH in the solutions may not occur. And what is buffer capacity? So buffer capacity means is the ability of your buffer to resist pH change. It's expressed as the amount of acids or base required to change pH by 1 unit. So when we are adding small amount of acid base, pH will not change. That is called buffer. So we'll keep on when we are adding, it produce the 1 unit change. So that is called buffer capacity. And a Henderson-Hasselbalch equation definition, the equation related to pH and pKa. pKa means ionization constant. The ratio of conjugate acid to base to acid means pH is equal to pKa plus log A minus divided by HA. A minus is acid, HA is a salt. Then determine the pH of buffer solution using pKa and salt acid ratio. So pKa, pH is equal to pKa plus log, it's a acid. A minus means it's a salt divided by acid. HA is the acid. So this formula, A minus is a salt, HA is a acid. Which of the following the best defines pH? So option B, the negative logarithm of hydrogen ion activity in a solution. The buffer solution is the best defined as, so option B, a mixture that resists change in pH when small amount of acids or base are added. What is capacity? Buffer capacity is defined as, so the answer is option B, the amount of acids or base a buffer can neutralize before a significant pH change occurs. The Henderson-Hasselbalch equation is used to, so option B, determine the pH of buffer solution using pKa and salt acid ratio. Neutralization curve in acid-base titration primarily represent, so answer in comment box. So all of you join in our WhatsApp community. You will get hands-out material and number of test series. Thank you. Like, subscribe and share. Thank you.